So this was built around the OMSI district piece of what we're doing, and as you saw at the beginning, the real focus here was OMSI, but the idea in my mind is that this becomes something like an infrastructure center. That's and I don't like the use infra center because I don't think it really covers what it does. I think it's the meshing of the mobility hub, the resiliency hub, and an infra center is what we really want here. And how do we go about making that combination a real platform um, for services? And so,
Could I ask, what do you mean by infra center?
So the idea of an infra center, I don't know if any of Stan's discussion about eco districts has soaked in. He talks about them a lot, but we don't talk about what they are. And I had not really understood this before I went back and did some research to try and understand it. And Tim sent me some stuff. But think about how services operate, right? So you know, in the same way as we think about the electricity, the old days of electricity being you generate electricity way out of the city and big, you know, plants, and you pump it into the city and it's consumed. And now we're starting to move to this idea of microgrids, which is dynamic energy resources within a community. And there's an optimum size for that grid, that node. I don't know what it is yet, but there's a right size to build that node with the right components in it to make it a resilient node in electricity. You can do the same thing with transit. You can do the same thing with water. You can do the same thing with waste. And they're slightly different sizes, but there's an idea that that when you build a node, you want to for optimum ecology, you want to set the size of the district that works with water or with waste at some level. We don't quite know what it is. And that was an eco district, right? How do you split up the city into nodes that are able to be big enough to handle their own waste, but small enough that they're not, you know, the whole city going down kind of thing. So the idea of an infra center builds off that, saying, and there's a piece of it I don't like, which is the idea that it's one building. And I think we've sort of got away from that, but I notice when Scott gives the presentation, it tends to be, because Scott started with this idea of a centralized district for, you know, when they started looking at OMSI as a district, they said, well, we have to build a central utility unit, which is a big space, which has all of the heat pumps and all of the electrical stuff all in one place. And we said that really just doesn't work. It doesn't work for us. It doesn't work. And so we got into this discussion about, well, maybe you could distribute the electricity, but the heating, ventilating, and air conditioning all has to be centralized or it doesn't work. And then PAE came in and they said, no, you can distribute that too. So we're sort of working this idea of how do you scale energy, waste, water, and transit appropriately for a community. And I like to have transit in there because I think it fits well with your low speed, right? How big a node is your last mile, right? Is it a mile? Is it smaller? How big is it? But it's a node, right? And then between those nodes, you do something else, high speed bus, or you do, you know, DC long range lines, whatever it is. But
Well, it's everything. It's walking, it's bikes, it's
right.
low speed. Yeah.
Yeah, it's low speed. So that was sort of the idea, and I'm not going to talk about that as much as the operating system that runs on it in Stan's words. So you know, here's the idea: a whole bunch of resources, be they energy resources or, you know, retail resources or water resources or whatever, but they all have to be connected because you're trying to manage them as an entity, right? That node needs to be managed as a node, not as a gazillion unconnected, unrelated services. and you know, I put through these two slides in just because they talk about the district itself, you know, I wanted them to have. And this is Sarah Architects' one building, and the idea here is that this is a community center. So it's shifted from being just a place where all the infrastructure is to being more of a community center. So it has retail in it. It has offices, it has residential, it's high density, so it's the node in the transit system. You know, they've sort of colored it here. You know, the blue was sort of the central utility, which I really don't like it being central utility. I'd prefer that be understood to be distributed around the buildings. There's some battery storage, there's, you know, there's a biking park, there's retail, there's parking. The tower is residential or office, and there could be two towers. The one on this side that's lower could in fact be another whole tower. So architecturally, they're sort of thinking of this as a community center, but they're also to some extent centralizing the utilities, and I think we've made the good argument that they shouldn't, that the utilities should be more distributed. And the PAE conversation reinforces that. So, so once you think about all the services that are needed here, I have these two slides. The first one is sort of people, the big guys, right? The Amorescos and the Putnams and the Sustainable Water, the big services who come in here, both the design services and the construction services. You know, these are just a few of the people we're already talking to. And they need to coordinate, right? And the conversation with the utility is with PGE here is, you know, they would like to be able to see all of the components and how they're responding, so as they can, you know, ask if they can set a window of maybe, you know, 30 minutes or 2 hours in which they don't have to heat the water because they've got a peak energy load, and they don't, you know, if they can reserve those times when things, other things are not peaking, then they can manage the electricity better. So they want to be able to see all of these units. And the second one here, you notice I put DCTC on there. The DCTC is a test bed, and all of these companies are involved in the DCTC. So we're working with a lot of folks that we need to coordinate. And how do we coordinate all of those folks? So that sort of starts to get into this discussion back to the infrastructure as a market or mobility as a market or whatever. What does that mean and what does that look like? Because
do these vendors and things, do they become part of the catalog?
Yes, they absolutely become part of the catalog. In fact, they almost define what the catalog is, right? Because the catalog is a collaboration between all these guys to agree that there is a consistent way of handling how they move data between themselves. Because if they don't coordinate, then none of this can ever really come together, right? It's difficult to get the parts to work together properly. So you know, what I was trying to show here is, you know, a set of devices and a set of services in the community, and they can be quite wide ranging. I mean, the easy ones to think about are stuff like if you had a solar panel or a storage device or a lamppost or a trash can, you know, you want them to know the existence of one another, and you want them to be able to trade off between one another. The solar panel needs to know how it works with the battery and whether it's putting power into the battery or whether it's you know, putting power directly into the lamppost and how it's sharing that, and whether the battery is ready to accept that power or if it's overcharged already, and how it has to respond if it can't put power into the battery. Can it trade that power outside the community, and when does it do that? All of those things are fairly complex, and there needs to be control. And the way that that's controlled today mostly is through a control center. It's through a you know, a Schneider control system, and they typically, in order to make all of that work, they make all that proprietary because they want to be in control. They don't want somebody somebody else's device being dropped into their network, because typically it'll disrupt it, right? If I don't know, somebody just comes along and plugs a car into my building, how do I know? How do I control what's going on? And so they see it as a control task. And the problem is that's not really very scalable, right? Once you say, okay, I'm going to build this building and I'm going to put a Schneider control system in here, and I'm going to plan it around how many batteries I have and how many heat pumps I have and how many solar panels I have, and then I lock it down and that's it, and I operate the building like that, then I can't come in the next week and say, hey, I've got a better heat pump, I'd like to drop it in, because you'd have to replan all the control system. So it's not scalable. And if you're building the site, phases at a time, what happens when you build phase 2? Do you have to know what you're doing in phase 2 before you put the control system in for phase 1? So you want it to be very flexible. You want this ability to add and take away various dynamic resources as you go.
So as the paper yesterday on Azure, for example, they were talking about this, and I assume this is similar to some of the other big guys. They were talking about having this operating system inside that was able to do just that now, be able to talk across without having to be their system. Is it just, are these systems not done well, or are they just?
They tend to be the way that a lot of applications. So there's technically all of this is possible today, and in some cases it is implemented. But the approach that is mostly taken to these control systems is to limit their complexity, try and minimize where there is variation and complexity in the system, for all sorts of reasons. But the challenge with that is this scalability issue and a privacy issue, which I'll get to in a second. But that doesn't mean they don't exist. The production versions of these things that are out there do tend to be more proprietary and more locked down. And it's partly, as we've talked about before, it's partly because there's a certain level of it, when you're controlling devices, there's a certain level of liability there that you want to control, right? If I'm Siemens and I'm taking over a building, my brand is on that building, my control systems are in that building. The approach tends to be to say, I need to be proprietary here. You can't just plug anything in, right? That's the mental set to this, for good reason, right? If you can get away with it, it does remove complexity enormously from the design of the system. But there comes a point at which you need to embrace that complexity, or you give up a lot of other things, including privacy and stability and extensibility and interoperability. So there are several communities that understand this, and I'm sure Azure is starting to see it, right? I was saying this morning, when I was talking with John, I was saying that I'd had that meeting with, 100 folks on the phone. The momentum is building, right? So yes, it's legitimate to say, can this be done? And is it being done in places? And is Azure looking at it? And I think you could probably answer yes to all of that. But I would say that 99.9, maybe even close to 100% of current implementations are in the old world, right? So intellectually, a lot of people are already starting to move. That momentum is happening, but the market hasn't moved yet. I mean, I was in a community in the early 1990s that was working with hypertext and Janet and DARPANET, and we were all talking about how this was all going to revolutionize the world. And you could talk to people about what it was going to look like in when all this stuff was deployed, but none of it was deployed. I mean, you didn't have Amazon, so there was a discussion. It felt the same way, right? intellectually, I can go to a meeting with Azure, and Azure will be talking about the internet, and I get it, right? But it's Microsoft. Why the hell aren't there any implementations of that? Why are they all still proprietary and locked down, right? The first implementation in the late 80s of an online shopping system was Prodigy, right? It was Sears catalog online, right? And you had to log into their catalog, and then you go through their catalog, which looked like a catalog. It looked like a book,
Here's Calvin.
of all the stuff, and you could pick what you wanted and then call them and make an order, right? It was a far cry from an internet shopping experience, and you could talk to people about where it was going and they understood it. And you could even say, I could build a version of it, but there wasn't one. So what I think I'm saying here is, this is where it's going. I almost have no doubt this is where it's going now. It hasn't gone there. So the opportunity to build a business here is equivalent to the opportunity to build Amazon in early 1990s, right? It doesn't exist. It's going to exist. It's almost inevitable it will exist. How do we get on that bandwagon, right? And do we expect, IBM and Intel and Siemens and Cisco and Microsoft to go after this? Yeah, absolutely. In the same way as Data General and Honeywell and went after the internet. And the problem is that their mindset is in the old market, right?
Yeah, they can't. It's difficult to change because of all the reasons. What's his name and who wrote the disruptive technologies, right? It's difficult to move those companies.
Well, it's part of the problem is that they have a foot in the existing world, and their focus tends to be, you're making $1 billion in market A, and you're making, very little money in a very speculative market B. Your tendency is to focus on market A.
Yep.
New company who comes into it and says, oh, well, big company owns market A, so there's no space for me over there. So I'm going to play in market B because it looks to me like it's growing. They're likely to be the successful ones when market B takes over. Right? This is sort of part of the innovator's dilemma that Christensen talks about. Right? Is that the new approach technically starts very inferior to the current approach, but it's on a trajectory that is very rapid, and so it tends to be that the incumbents, because of their commitment and their success in the older markets, tend to move slowly, and it's very difficult for them to get a mindset that's truly new thinking. And a lot of the established communities that they have, their senior managers and other people, their head is where they've had their success, right? Their head is not this, this crazy stuff that the young kids are doing kind of thing, right? The attitude tends to be. So I think I guess what I'm saying is, I think we're going to see everybody talking about this. And the question is, can we capitalize on it? And can we be the, the Amazon or the Dell or the Google, right? Who, when the internet was being talked about, they weren't there at all, right? They didn't play a role.
Yeah.
But they're the ones who won, right? And they may have even been the second or third round attempts. They were certainly a long way after, Yahoo was way before Google, and Prodigy was way before Amazon, but they got it wrong, right? And so that there's huge opportunity.
Yeah.
Sorry?
Timing was wrong.
Timing was wrong. Timing was wrong, and yes, timing was wrong. In a lot of ways, right? It was to whether the market was quite ready when they came in, whether they piggybacked on the right versions of the technology, whether they really understood the new business models, whether society was ready for those business models. I think those are all good questions, and I think there's as big as this opportunity is, I think you know, there's still plenty of space to fail, right? And it might not be the first versions of these things that succeed, but I think it's getting more active. So so the think about so what we're trying to show here is a couple of things. So just the structure of it is the data is closer to the edge, right? Discussion about edge, you know, push the data to the edge. This is not talking about, this is the antithesis of a data lake or a data warehouse, right? Where you centralize everything. That doesn't mean that they can't work together, but this is not about bringing all the data to a central place where you can look through all of that data and sort of make decisions. In fact, if there's a criticism about it, it is that doing data analytics appears to be harder. I think in the long run, it's not. Actually, it's much better. But in the short term, when I presented this to a lot of data scientists, they don't like it because they want to bring all the data together because that allows them to do data analytics across that data. So centralize it all, and then I can do stuff, which is exactly the business model that Facebook and Google and others use, is they bring all that data together and then they can do some very interesting analytics on it. We've gone the other way. Push all the data to the edge. You own your own data. If there's a camera on the lamppost in Portland, it owns its own data. And if you want to get at that data, you have to ask for it, right? That's why the data is on the outer ring here, and the identity, the person or the device, is inside that. So if you want to bring it together, you have to send it towards the center, but the individual or the entity is in the path of that data coming together. It's a decision point, and that matches very well with regulations like the GDPR, when you share data, you share it for a purpose and only that purpose. And if you want to use it for another purpose, you ask again, right? That the individual who owns the data ought to be consulted as the data is used. And there's no way to mandate that that cannot be abused, but it does draw a line that allows you to know that you're crossing that line, right? In the same way as I can't stop people coming into my home, but everybody knows that once they cross the threshold, even if the door is open, that they ought to do that with my permission. That's socially understood.
Is
Right?
there any disadvantages or advantages right now with technology in terms of storage? I mean, typically, if you store at the center, you know, you can get faster bandwidth, faster times, faster, you know, or is just the advantage now with 5G, better storage devices, better ways? Is technology allowing better and better ways to move it to the edge, or is it?
It's a really good question, and so the first thing I'll say is uh, the edge is both physical and logical, and in this case, I'm talking about the logical edge, right? Which means that you own your own data. Physically, where you keep that data is completely up to you. You could store that data on a Google Drive, but logically, it's your data. It's encrypted to you, and where you store it is irrelevant. You can put it on a thumb drive, which would be physically on the edge, right? It's about as far as you can get. Or you can put it on a shared drive somewhere, but logically it's yours. You own all the keys to how that data is accessed. So that's the first thing, is the separating out the physical edge from the logical edge. The physical edge, choosing whether to put it at the physical edge or not, has slightly different weighting to it, but being able to do either is important, right? So let's talk about that from a transaction perspective. So you and I want to do a transaction. If the data is at the edge, in other words, if you own all your data and I own all my data, us getting together and doing that transaction is the simplest thing we could possibly do, right? We're just sharing data between the two of us. We are in total control of our own transaction, right? If all of that data was held at Google or at Facebook or at your bank, right, we have to involve a third party. And that third party is likely to be a busy party if everybody does it, right? In other words, if it's your bank, you have to wait in line, right? So you and I want to do a transaction and our bank is involved, we might have to wait in line. And digitally, the same thing happens. So imagine that I'm jumping onto a TriMet vehicle, and the TriMet vehicle has all the data about who's in it, and about how much it costs to get on and how much it costs to get off. And I have all the data about my bank accounts. All the transaction needs to happen is between me and that vehicle, right? That may seem silly, but that's the only transaction that needs to happen. It's instantaneous, right? If all the information about the vehicle and the pricing and the rest of it was in a data lake in some central location in Portland, and all of my data was in some data lake somewhere in Google, it might be out in the Dalles, and I have to do a transaction between those two, it could take, it could take a fraction of a second to do that. It could take, how the hell does that work, right? I'm jumping on the train. Does it mean that after I get on, they find out that, that I'm on the wrong train and the doors are closed? I mean, you want those to be instantaneous. The one that's maybe a little bit more to the point is I turn up on a rainy day, I turn up to get my Bike Town bike out of its rack. I'm standing in the rain and I identify myself, and then I have to stand there for a second, getting soaked wet, while it checks back with the bank and it checks back with no, I don't want it to do that. I want that decision to be made right there, right? Now, how do I do that, right? How do I make that happen? What's more is, when I go to a different community, so now we're talking about smart cities. So the whole of the United States is using the same framework, right? And I live in Portland, but I'm actually doing a transaction in Austin, right? Does Austin have to check back with Portland to find out all the information about me before it can let me have a Bike Town bike, right? No, I should be able to do the transaction right there. Now, there are some weaknesses to that, in that, how is my data at every Bike Town all around the world? Well, obviously it's not. So it has to work a bit like the way the internet works. So what the internet does in that situation is it buffers information local to where you are, understanding that I don't go from Portland to Austin in one big fell swoop. There's probably a track that goes on, and data's following me and connections are following me. So I turn up every day, I turn up at a Bike Town rack and get a bike in Portland. That rack will know who I am in the same way as my local store will know who I am. It will say, there's, in the last week, 200 people have checked out bikes at this rack, and I know who all of them are. And if any one of them comes up to me and tries to identify themselves, I'll know them. I'll recognize them the same way my local store would, right? But if somebody comes in from Austin, yeah, I'll have to do one-time transaction, but then all the data's right here. The next time that guy turns up, I'll recognize him, right? I'll be right there. So what does that do? That allows the system to scale, because every transaction is not having to go all over the country to find things. There are intermittent transactions that move data, but they're fairly rare, right? Most of the time I'm working around my same community doing similar things in Portland, and all of my data is pretty localized. But then I fly to Boston and I'm in Boston for 3 weeks. All my data sort of migrates to Boston for a while. It doesn't get forgotten in Portland. When I come back, it's probably still there. But if I'm in Boston for 6 months, very good chance it'll be lost, right? That kind of buffering is happening all the time in the internet. When you buffer up information, when you make a request on the internet, if other people are making the same request, it doesn't always go back to the same page, right? If everybody in Boston was coming and hitting our website, the Urban Systems website, it would be buffered all over Boston, right? And when people are making that request, they're actually not hitting our website unless they specifically request to do an update, right? So that's why you sometimes see old pages not clearing, not going out of cache.
So
right?
is this technology available today, or do we have to build it?
The yes and no. This is why I'm really interested in the solid community, and I'm also really interested in blockchain community. These technologies exist in the same way as, as a computer language or a computer operating system exists. The components are all there to build this, but the applications don't work this way. What we need to do is to move the applications, right? So if I was, right, I'm talking to TriMet about their multimodal transit app, which they have, and it works, and it's good, but it's centralized, right? Every time you make a request, right, you have to give it your information, and it will remember your information if you let it, but then the information is central, right? What I want to be able to do is to push that data to the edge. You should be able to go to the transit app and say, I want to travel across Portland, and it should know that you don't know how to ride a bike and that you want to use electric vehicles, like I was saying with John this morning, right? It should know that, but it should know that in your wallet. It doesn't need, when it's doing a transaction with me, it doesn't need to know that, right? So why would that all be in a centralized database? It's only, that's information that relates to you, and unless you're involved in the transaction, that information shouldn't be anywhere in the decision process. It shouldn't be in the database. It shouldn't be anywhere. It's just your data, and only should be accessed if you're the one in the transaction. And the advantage of that is we're not searching through databases of thousands of people. You're doing the transaction. There's no reason to go look to see through a whole list of people who rides bikes and who doesn't, right? Do you ride a bike? Yes. Okay, then I'll show you bike routes, right? It's only looking in your database, and that's 50 records or something, right? It's much easier, much quicker, much more agile, right? So then what do we have to do then? Now we have to be able to say, okay, so let's disaggregate. Let's pull the data out. The data doesn't have to be centralized. So I'm just using local data. I'm using data on a device or of a person, and I'm transacting that with another data on a device or a person or a company. But what do I need to do? I need to know what a transaction is. I need to know what that application is doing, and I need to. Before I run that application on my data, I need to know that it does what it says it does. So I want a contract for what's going on here, right? I'm gonna get on a train and go somewhere. I would like to know what terms I'm getting on that train. You can't change the price while I'm sitting on the train. I want to know, hey, here's the list of what I'm going to charge you. If you get off here, I'm going to charge you this much. If you get off here, I'm going to charge you that much. I want to know that. I want a contract. It doesn't sound like a contract in that sense, but digitally it's a contract. It's an agreement that I'm getting a service and I know what it is and it will be executed. And I want to know that that service will actually be executed, that when the TriMet wants to know that I can't get on unless I can pay the bill, and when I get off, the bill is paid. It's just done. There's no debate about it. I can't get off and negotiate and say, well, I didn't think that, I think that's too much. No, that was in the contract at the beginning. There's no debate about it. And then finally, I want to be able to say, wow, there's all these transactions happening all over the place, and every now and then something bad's going to happen. And I want to be able to know that there is a defined, immutable record of that. If I say, hey, I gave Ken a lift to the airport on Tuesday, and he paid me with a $30 bill that was fake, and Ken says, no, you didn't give me a ride. I've never seen you before, never heard of you. Where do I go to make sure that there is a record of that, right? Because I've got it in mind. My wallet says yes, but Ken's deleted it from his. So who the hell is telling the truth here? So you really want an immutable record. At some point or another, you want to know the transaction happens. That doesn't mean it doesn't mean that transaction has to know personal information about you or personal information about me. It just needs to say, there was a transaction using this contract between Wilf and Ken on this day at this time, right? And that transaction might actually change the state of things, right? It might start to change the state of the fact that Ken's location is now in a different place. So there's all sorts of ways in which that works. So this is really effectively turning existing applications on their heads. Instead of saying we centralize all the data and then we run applications that are centralized on that central data and give you what we think you want based on that data, it's saying you come in with your data and you choose what contracts to agree to, what programs to run on your data, and you're therefore engaged in every decision that's made. No decisions can sort of happen around you like they do, hey, I think that Ken is interested in buying a car, so I'm going to show him an ad about a car. And Ken says, fuck, I bought the car yesterday. I don't need the ad. I should be able to tell you, please do not show me any adverts on cars, right? And so it sort of puts things around the other way. So all your questions are right. I think I could pretty much find all the libraries and all the tools to build these things now, which is fortunate because it's a hell of a lot of work and we're not going to do it ourselves. In the same way as Amazon didn't have to invent HTTP and URLs and you know, and the communication, the 5-level communication stack, and they didn't have to do all that. They didn't have to invent, you know, a Cat5 cable, right? All of that stuff had to be in place before you think about an Amazon. All of those pieces are coming together, and it is now becoming possible to think about building applications in this new environment that is the web on its head, in a way. Maybe according to Tim Berners-Lee, the right way up, because Facebook and others implemented it on its head because it was easy to build a business model that way. So this is turning it up the right way and saying, okay, it's distributed and people are in control, which was the way we meant it to be in the first place. Yes, of course, it's possible to build it that way. That was the way it was intended to be used, but it's not the way the main apps are built. There's no social apps that work this way right now. There are no transit apps that work this way right now. And when I talk to people, I mean, you know, Trillium and Tosny, of course, I've had these conversations with them, and I say, this is how we want to build it. And they go, oh, yeah, I think we could do that, right? It's not a technical challenge. It's oh yeah, no, that wasn't the way I was thinking about it. Mostly the way that's not the way people are thinking about it is they monetize the transactions. The whole idea is to bring all the data in and then monetize it. That's the business model they're using, right? So we've got to reverse that business model, and we've got to create a set of new business models about how companies can be successful and make profit this way up, right? That's the key. And that's what we're trying to do. So let's go a little bit further on. Let's see, next slide. So all I wanted to do here was to talk about the fact that in the OMSI situation, things are changing over time, right? So even if we got it all right at the beginning, this is sort of reinforcing this. You can't have a control system that's not extensible and non-repurposable, because whatever we design for OMSI today is going to be out of date in 10 years time, right? We don't have flying cars and robots and augmented reality goggles today that are being used, but in 50 years time, they'll all be around, right? And so we need to be able to change out the parts here in a fairly seamless way as we go. And then this graphic is really trying to lay out how we go about building the system, how the pieces come together to provide this environment, and the role that a nonprofit 501c6 plays in bringing the community together. So the lower half of this is the nonprofit world, is the contributions that people make to create the environment that is necessary to do this, and that is done in a pro bono kind of way, right? That's done as a nonprofit exercise. And the reason you do that, the reason that PAE and DIRT and Amoresco would do that, is because the upper level is where the businesses operate. And you have an advantage as a business if you have played a role in defining the framework and the rules around which the game is played. So you want to have a game, you want to sit together and define how the game is going to be played, and you do that without charging money. You don't get paid for that. But once you've got that game right, and that has to be agreed to by all the players, you can make money playing the game, right? So if you come and you've never played a role in defining what the game is, you can still play, but it may be more difficult. So what you typically would do in an environment like this, if you want to get in the game, you join in the bottom and you contribute. You say, hey, I've got these new features that I want to add to boilers that are going to go in buildings, and I want to define an API, a standard for how that information is traded because I have these new features. You do that on the bottom, and then when you come to the market on the top, you can say, yeah, I can now plug in. Everybody has agreed that this is how they talk to my features. So it's not a way of, you know, there is self-interest here, right? That when the game is played right, you get both the community that you want with the right game and the right rules, but you also get to build a business and make money. So this is trying to show how that works and where the catalog plays a role, where standards play a role, where Digital City Testbed plays a role, right? That's all along the bottom. And then where you do design, build, and operate these communities or fleets or whatever we do. And that's pretty much it. You know, this was really just sort of finishing off the you know, what we have to do next in the way of putting a competition or an RFP together to have these players define their roles and start to come together.
Well,
yeah.
why don't you go back and you can, for that, how big do you, how many people do you want to get out to that RFI?
So, so this is going to happen in pieces, right? So for the OMSI community, it's probably energy, waste, water are the key players. We need to have major players in each of those areas, and they need to be competing in those areas. If we were doing this for transit, you'd want to have public transit and private transit play a role, right? So you'd want to have the Ubers and the Skip, and you'd want to have TriMet, maybe King County, right? And they help define the game. They start by defining the board. And then when they go to play, other people can come in and start to play. But you don't have to worry so much then. Once you've got the rules right, it should be self-perpetuating. Other people will join and will lobby for how the rules get changed to make it a better game as they play, right? But they need to be able to sit on both sides of that table, but with very different hats. On one side, they're looking for consensus.
They need to be on both sides of it, or they need to be offered to be on both sides. So what I'm saying, into building the rules, but I'll wait until you guys are ready.
Yes, you can do that. Typically, though, that you're at a bit of a disadvantage when you do that. There are things you do on the open side to create, right? If I come into a game that is, you know, I'm building a boiler to go in a building, and my competitor defined what the interfaces were, then those interfaces work with all the features in his device, and I have to comply to that. Right? So if I've got a special new feature that is my differentiation, that is my value, the reason I'm trying to sell it, and it's not exposed in the game, then I'm at a disadvantage, right? So I should go back and say, hey, there's this additional feature that my competitor doesn't have, and I want that added to the API, right? So if I come in and I'm also ran, I'm just competing on value, I'm just competing on price, then I can probably come in without bothering. You know, if there's no differentiation, then I can just come in and compete on price. But if I want to differentiate, then I need to play the game.
So defining the specifications for that, you're going to have specifications that are related directly to the boiler, right? If you're using that as an example, I needed to do this.
Yep.
You're also going to have ways that boiler interfaces to the rest of the community, right? Your idea that this is a distributed system, right? Or not looking at one building at a time. That can get pretty complex.
So that's why it's a transaction between two entities, right? So we're not trying to solve the problem in general, we're trying to solve the problem in specific, right? So let's say I'm in Portland. Let's say there's boilers all over the world. Everybody has a boiler. And there's an API for how to talk to those boilers. And it has 3 control points. It's turn the boiler on, turn the boiler off, set it to half boiler speed or whatever, right? And I come along and I say, hey, I have a truly variable speed boiler. I can set it at, you know, 0, 5, 6, 7, 8, 10%, 20%, 30%. That's my boiler. I can expose an API that's on, off, and 50%. So I can sell it, but I can't differentiate it. Right? I can just sell it. So what do? Well, first of all, I go, okay, I want to change the standard. And I get an agreement that there's a new standard, but now do I have to get everybody else to change the world? Over time, yes, I do, but I can sell it to one building. I can sell it to OMSI who cares a lot about being able to set it at 72%.
Mhm.
And all they have to change is how they talk to the boiler, right? And if that piece of software now that says, okay, this is how my electrical system, my utility talks to that boiler and sets it to 72%, I only have to do that in one building because I'm not fixing the world, I'm fixing that building. And at that point, all the other utility guys go, hey, shit, if we buy that boiler and use the code that PGE uses, we can be more competitive. So the adoption starts to move rapidly. You don't have to force adoption. A better system in the game will be advantageous for everybody to adopt, right? So think of it that way. It's you know, on the lower side here, you're setting the rules to the game, and you don't have to be involved in that. You probably, you know, you'll get some nonprofits that will be involved in that and not play in the upper level. They're just trying to do good in the world, and they're funded by wealthy people who say, hey, we want to, you know, we want to improve the way that things work. So there are people in the bottom that don't play in the top, but there are also a lot of people in the top who are just saying, hey, I want to build, you know, I want to build a boiler that that competes just on price, and I'm not going to spend any of my resources going to the standard setting stuff. I'm just going to read the standard and deploy as quickly as I can. And that's fine too. What you find is that if you want to make any differentiated value in this game, you probably want to play on both sides. If you want differentiated value, you have to go out there first. And it's a hard game to play because people, you have to experience it to, and it's not a new thing. You know, back in the 80s, when digital equipment VAX was out there, we were early on in sort of standardizing things like languages. Fortran was the main language that was used for all scientific work on a digital equipment VAX. You know, the Fortran was a standard, and everybody wanted to use the standard. If you used, you know, anybody's, you know, there was Data General, and you know, they all had their own versions and their own extensions to Fortran, but you didn't use those extensions because typically you use them in a program, and a year later, because they weren't in the standard, they wouldn't be supported anymore. Digital equipment drove the standard. So if you got an extension from digital equipment, you knew it was going to be in the standard next week, right? So you used all of digital equipment's extensions. So people bought VAXes because they were technically ahead of Data General because digital equipment was driving the standard. And so those all got rolled in, and you knew that Data General would be using the same extensions that digital was using now next year because they were in the standard and they had to implement them. So following the standard rather than leading the standard was very damaging to people like Data General, and very, very positive to people like digital equipment.
I was thinking more in terms of the competition and how you go out to these vendors to get them involved in the competition, or how you write the RFI to get them involved, and how you negotiate. You know, at the end, you're going to sit down with these RFIs and these companies together, and there's different ways to do it. In medical, we would you bring the vendors in and actually help write the RFIs with different ones, not necessarily specifically for them, but to get all the information that was out there. You know, that guy who can do 72%, you may not know about, right?
Yeah.
You know it's important. You may see it in red, but you know they developed it for a reason, and you want to know why. So that understanding of how to write that RFI is pretty important.
So think of the RFI really as the starting point. You've got to get started somewhere. Once the community is there, once the game is being played, a lot of this happens automatically. You don't need RFIs. The problem we have today is that the game is not on yet, right? It hasn't been
Yeah.
built. So we have to create the game, and that's the reason for the RFI. Let's go find those starter games. Let's go find the 2 or 3 big companies in energy, 2 or 3 companies in water, and 2 or 3 companies in waste, and get them to come and say, here's the game, help us create the rules, and we'll let you play. Right? We've got the money, we've got the building, we've got the space. If you want to play, we're setting up a game. Come along and play. Now they'll help define the rules, and then we'll pick.
Yeah, and this is more logically will be the way that other places build off of. So this could be the next.
Once the game is started, it will be self-perpetuating, right? Because then people will come along and say, oh my, if we get it right, they'll come along and say, oh my God, OMSI's fantastic. Let's do something like OMSI. Let's use that. Who were the vendors who did that? And they'll start with the vendors that we picked. And they'll say, is there anything better? And of course, at that point, there'll be 5 people knocking on the door going, Frig, OMSI was brilliant, but we can do the water better than OMSI did it. We can improve on that, right? And if that's the case and they can show it, then that next guy will bring it in. And if it fails, people will go back to what worked with OMSI, right? And so what you're trying to say is we're setting the initial baseline for the game. And from that point on, all of the other implementations will make small iterations and it will evolve. They'll either get better or worse. The ones that get worse will be dropped. The ones that get better will be adopted, and hopefully it will continue on. And that's what will build out the catalog, and it will define the catalog. And there'll be situations, it's not just better or worse, it's in this situation, this was better, in this situation, that was better, right? And so those variations will allow the adjustments on the top line, but they will also not allow lock-in. It won't be that, oh, well, in OMSI, PAE worked with DIRT, worked with Amoresco, and so they worked out these interfaces between them, and I can't drop somebody else in because if I drop Amoresco, I have to drop DIRT and PAE, right? Because those are open APIs, Renewable Energy Trust can come in and say, I can do what Amoresco was doing in this partnership better than Amoresco would, and let me show you. You don't have to share anything with me, it's public.